Hello, everyone. Welcome to today's session. We're so glad you could join us today. I do have a few housekeeping announcements before we get started with today's session. And while folks get logged in, we are going to have a webinar next Wednesday, February 18th, on Boeing exoskeleton iterations, Succeed, Fail, Learn, and Sustain with Christopher Reed. And then the following Wednesday, on February 25th, we'll have a webinar on retirement inequality in older workers with Nari Reed, PhD, in the California Labor Lab. For more, you can visit us online at coeh.berkeley.edu/webinars. And on behalf of the education and research centers throughout the country, we're pleased to present the Industrial Hygiene webinar series. This is a collaborative effort on behalf of each ERC's continuing education program and aspires to provide access to current research supported through NIOSH ERC programs. Thank you so much for being here and joining us today. Today's webinar, TLV User Guide and Heat Stress Management Plan, is presented by Thomas Bernard, PhD, CIH, FAIHA, and the Sunshine Education and Research Center. You are going to be muted during this presentation. If you'd like to ask a question, you're welcome to enter it into the online Q&A box. We'll be saving time at the end of the presentation to address as many questions as possible and can also welcome clarification questions during the session. We'll also have the chat open, so feel free to use it to participate and join in on the conversation. This presentation is being recorded and will be made available on the Center for Occupational and Environmental Health YouTube page within 5 business days. And all participants who logged in with their registration email for the full live presentation today will receive an email tomorrow with a link to an evaluation form that will qualify you for a certificate of completion with 1 continuing education contact hour. Once the evaluation is completed, you'll be able to access and print your certificate. Without further ado, it's my pleasure to welcome our presenter for today, Thomas Bernard, PhD, CIH, FAIHA. Dr. Bernard is a professor in the University of South Florida College of Public Health. He has more than 45 years of experience with occupational heat stress in both research and practice. He is a past director of the Sunshine ERC, former member and chair of the ACGIH Physical Agents Committee, for which he earned the William D. Wagner Award, and a member of the ISO Working Group on Thermal Stress. Thank you so much for being here today, Dr. Bernard. We're really looking forward to your presentation.
Thank you. I'm really happy to be here. And let me see if we can bring that presentation up. So we're going to talk about the ACGIH User's Guide. And I want to tell you that that's just sort of a leaping off point into, I think, my larger message about a heat stress management plan, and specifically a template that we've developed. And this is our rollout announcement for that plan. This is my contact information, and both email and phone. I tell people to always leave a message on my phone if they when they call. I was just telling Michelle I'm kind of heading toward retirement, so I throw in a special thanks for those past 35 years I've been with USF, and I'll call out in particular Candy Ashley, who I've had the pleasure of working with as a colleague for 30 of those years. In terms of acknowledgements for today's presentation, first I want to acknowledge June Spector, who has been patient with me over the last few years and has reviewed really many drafts and iterations of what now is this template. And then also to Dawn Ellswick, who also reviewed the template and helped me with some things. In terms of declarations, no matter who helped contribute to this in support over the years, the opinions are mine. I don't have any conflict of interest to declare, but I will tell you that I'm very biased. And so take everything I say with that grain of salt. Now, heat stress is receiving, of course, of a lot of attention in the last few years. And the obvious ones are that excessive heat stress is going to lead to heat stroke. And we do have about 40 cases of occupational heat stroke a year, and these are often fatal. We have about 40,000 reportable cases of heat illness. Some people might not appreciate the fact that also the risks of acute injury go up with heat. That's a well-documented phenomenon. And I take the safety approach that if you have an accident, that can be injury to the individual, but it could be injuries to others, may damage equipment and harm the environment. So I think we need to think about that potential for accidents is really being related to heat. And clearly, employees can't get as much done. And if they really try to push to keep the same level of productivity, they're likely to hurt themselves along the way, either with accidents or serious illness. So this really becomes an important topic to address. For today's webinar, I really have a couple of goals. One, I want to describe this practical template for heat stress management. I've really have tried to develop it for small and mid-sized employers so that it's easy for them to, with minor modifications, to plop it down into their other health and safety programs, either alone or perhaps with a consultant or an advisor. And I'm also hoping that from the perspective that we offer, that others may also benefit from this. We're in that rollout process, and this is the kind of grand announcement, if you will. But we're going to take these announcements with the overview to the Global Learning Symposium, to the American Occupational Health Conference, as well as the AIHA Connect. So we're really trying to get this publicized and out there. We've got several 4-hour workshops scheduled, and we're looking to do a few more. Then there's going to be online materials. Hope that the USF website for this program, and I'll give you a link to it later, will be up very soon. We're going to do a couple of webinars, online material for the ACGIH Academy, also the USF OTI Education Center will be offering this, as well as the USF College of Public Health Lifelong Learning Academy. So we really hope that this becomes widely available, and I hope I've convinced a couple of you to be apostles for the program. So we do. I want to first emphasize that really the starting point is that guide for the control of heat stress and strain by the AIHA, and that really is an evolution from a long series of heat stress TLVs from the mid 90s to now. And I remind everybody, you do know about the TLV booklet. The documentation for the TLV really is also a good source of information to understand the evolution of these. I then took to build this practical template. Started with the heat stress guide. Then during this development process, OSHA published their draft rule in the Federal Register, and there were some kind of interesting things that came out of that. And so I have adapted my thinking with some of what's contained in the draft rule. Then the University of Houston at Clear Lake developed an extensive template as part of a hardwood project for OSHA, and it's on the OSHA website. And I was kind of inspired by that, and also by another program developed by Don Ellswick as a template. And what I did was really took templates that were really very rich in information, and then tried to reduce it down to something that I thought was readily adaptable. And so that's the Sunshine ERC, Heat Stress Management Plan template, and associated documents. And again, I'll remind you as we get to this end, is that this kind of becomes the Bernard view. So it's not that it's sacrosanct, but I think there's some lessons that I've learned in trying to get this down to a usable product. It's always worth mentioning that NIOSH from really the early 1970s up to the third edition of the criteria document for heat stress is always laid that foundation, and becomes an important source of background material, as well as the preamble to the OSHA rule. So if you want some rich sources of detailed information, those really are two places to go. Okay, now in the heat stress management plan, I like to think of it as having 5 features that are in this risk management model. And the first is the traditional IH approach to heat stress is you identify it and then you put in your prevention practices. And really in this model, what you're trying to do is manage the probability of having a heat-related illness. And then in this model that I'm using, when you have heat stress, it's not a matter of if a heat-related illness is going to occur, but you really plan that there's going to be one, and you just don't know when it's going to happen. So heat stress is going to lead to a heat-related illness. It's a probability matter. If you're a large employer, you're more likely to see them more often than if you're a small employer, which may be years between serious heat-related illnesses. But the third component of this is when there is an illness, and we know there's going to be one, that you have a mitigation plan in place so that you're managing the consequences of that illness. This is going to be a constant theme, either implicitly or I'll mind you explicitly as we go through this conversation with you, that we really have to pay attention to this end of things. Then the fourth component is closing the loop. So whenever we do have a heat-related illness that's reportable, we ought to learn from it. In fact, I would even argue if you have a series of just first aids that we ought to be learning from it in order to get better at managing the probability. Then in a systems safety sense is once you make decisions here about what levels of heat stress you're going to tolerate, and then the accompanying risk that you're going to have a heat-related illness, you're accepting that risk. So it's not a matter that, oh my God, I don't know where that came from. Every time you kind of up that level of heat stress, when we talk about levels of heat stress in the program, you're accepting kind of more and more risk. You need to do more and more to prevent it where you can. And really the burden is on you to make sure that you manage those consequences because you're going to own the outcome. That's it. So those are the 5 features that I like you to keep in the back of your mind. Just a quick summary of the ACGIH guide is the TLV talks about, the booklet talks about 4 methods of assessing heat stress, and that's continued with a little bit more detail in the guide. And what's important of those 4 methods is that looking at that traditional TLV curve, that trade-off between the level of heat in the environment and the metabolic demands is literally the TLV that we're trying to promote. And then there are one kind of qualitative exposure assessment, the screening method, and then methods of more detail and really more expertise required to work on them. Another key element, and I'll show these to you in a minute, is the severity levels. And so how we think about different levels of severity in the context of heat. And then also, very important in terms of the template and my conversation with you, is that it provides the outline of a heat stress management program. And I want to emphasize especially the policies. And then I kind of riff on the theme of tiers of interventions. All right, so the heat stress severity based on a healthy, hydrated population is that if you're 3 degrees C WBGT is implied, hopefully in context, but at 3 degrees less than the OEL, that's really the action or alert limit. And but anybody below that, even if they're unacclimatized, is likely to deal very well with the level of heat. So that's acceptable. And then caution is that territory between the unacclimatized and the acclimatized line. And at the acclimatized line, again, it's a low probability of an unsustainable heat stress exposure for anyone who is acclimatized. Then what happens is and this bumps up by 3 degrees as we go to moderate, high, and extremely high. At moderate, the unsustainable exposure, so we lose thermal equilibrium, will occur in about 10% of the exposures, with a low probability of a very rapid heat gain. And then as you can see, as we go to high and extremely high, those proportions of rapid heat gain become more and more important. So that is that picture of increasing risk. And then the ACGIH divides the interventions into 3 tiers, where tier 1, it begins when you start to have exposures above the alert limit, which is when we really traditionally say this is where the bound to heat stress begins. And then with each progressive step, more actions are taken. Some of you may be familiar, in fact, I'm going to presume most of you are familiar with this table from the OSHA rulemaking process. And here's what I want to call your attention to is, first of all, there's just 2 levels of heat stress. So basically, when you're above the occupational alert limit, these are coming into play, and they're what you would guess: identifying hazards, having an emergency response plan, training, a written program, drinking water, having a break area. Then when you're above the occupational exposure limit, or the TLV or the REL, then you add on to those basic interventions, a rest break, begin a buddy system, and have a hazard alert. That's a pretty simple process for that increment of heat stress. And so when you look at the OSHA core requirements, It's have a written plan, designate the safety coordinator, who's the person on site who's going to monitor the environment and take action, get employee involvement. Remember, this is a program standard, and I'll repeat that again. Review the program after any event, and then make it, of course, available to everybody. The two observations on this OSHA program that I want to emphasize to you, because it's what I'm bringing also in to the template, is that you need a written program. And I'm hoping that this becomes a good starting point for the what I call low resource employers. They're not likely to have a full-time industrial hygienist on board to help. It involves employees. If someone suffers a recordable heat illness, there's a review and ask what didn't work, review annually. And so that is it. It's really designed to be a continuous improvement program. The other thing that I pointed out to you quickly when I showed you that little checklist thing is really once you're above the OEL, it's only adding 3 more things. One is a heat alert, let everybody know you're above the OEL. Take a rest break every 15 minutes out of 2 hours. I'm sorry, take a 15-minute rest break every 2 hours. And then there's also a supervisor or a buddy system, but there's somebody who's responsible for keeping eyes on, or in the special cases where you're working alone, some means of communication. All right, so when I take these two ideas of the guidelines and what I learned from OSHA, here becomes the template for interventions that's here. So the severity levels are exactly the same, but there are now 4 levels of intervention versus 3. Um, and really this level 2 or intervention is the one that just really lifts right out of the OSHA draft rule. And then I'll remind you, because we are working with a risk management model, is that as we go down the severity chart, we have increasing risk. So permitting people to work at level 2 over level 1 has extra risk. Level 3 over level 2 is additional risk. And of course, level 4 over the other 3. So you're accepting more risk as you work there. Okay, I mentioned that I'm doing some workshops on this. They're divided in 2 2-hour modules. Really, the first 2-hour module focuses on the template. And what I want to do today is spend really the emphasis on policies and on recognition and first aid. And I will kind of float over the others. Now, and by the way, for this QR code, I'll flash it up at the end of the meeting as well. But if you go there, you'll find a box file that has 4 documents in it. One is that basic template that I've been referring to. There's also a supplement to that template that has a little bit more details. And then also 2 Excel workbooks on estimating metabolic demands and heat stress levels, and also on work rest cycles. And I'm operating on the Creative Commons license that you can go ahead and use this and adapt it. I would just like the recognition. Okay, so the heat stress management plan. And I'm going to step kind of through the template on this. Not kind of, that's what I'm going to do. First 4 sections are straightforward. There's an introduction, and in the template, the introduction uses the risk management model. Nobody needs to be wedded to that model. They can put in whatever they want to do that's consistent with their other health and safety plans. what is the purpose, the scope, and I provide some language on what I think the purpose should be and what I think the scope should be. But again, the user that implements this owns it, and it has to be theirs. Written policies, and I've already highlighted that I want to spend some time on that, are in section 5. And I'm going to go through these 5 policies in slides because I do think they're important. So first is the assignment of responsibilities. OSHA says you got to have somebody on site that's making decisions. I agree with that. And it's the second point. I think there needs to be somebody who's in charge also of developing and managing this program. And it's not likely to be a person on site making decisions, but somebody who's helping to uh, put the entire program together. They'll have ownership of the written program, and then be responsible for updating it. And then, of course, there are other positions and roles as appropriate. And I've laid out the crew members, crew supervisors, second level supervisors in addition to those. But again, those are consistent with the way they organize. Policy on heat stress hygiene practices. This includes water, and that's a check mark on OSHA, and I think by now a well accepted need, but it's also other things. Heat stress hygiene is what individuals do to protect themselves. The individual then is responsible for practicing it, but management needs to support the individuals and minimize the barriers. Policy on self-determination. There should be a stated policy that encourages workers to break when they think they should. Oftentimes, people say, well, of course they can break. And then I'll just say, well, where is it written? So again, putting it into a policy, and I'll remind you of the obvious. There's a natural tendency for the least tolerant workers to really push themselves to keep up with everybody else, and add on to that new workers trying to keep up. And then also, if you have a work incentive program, that's going to discourage breaks. So there has to be a mind on that. A policy on acclimatization. Nobody's going to argue that there's not a physiological improvement in heat tolerance as you get exposed to heat. I will argue it a little bit differently. And so I think making a policy that allows for acclimatization of new or returning workers, and remember that during a heat wave, people are unacclimatized to that new level of heat. So it's also during heat waves. Now, where I really try to insert, I'm not a believer in schedules. I just think that that acclimatization period is really all about vigilance, keeping an eye out for who might be the least tolerant worker and making sure that they take breaks and remind everybody to do that. And then have some work practices when you have new or returning workers that you may allow them, assign them to other jobs, or take extra care in reminding them to take a break. This position, we've just received notice in the last week that an editorial on the role of acclimatization has been accepted in the Journal of Occupational and Environmental Medicine. And so when that's out, I think that will, I think, explain our view on ours being Larry, Kenny, and Candy, Ashley, and myself on the role of acclimatization. And there's parts of what's in the editorials also in the February issue of the synergist. Policy on early recognition. We want people to be really aware of and sensitive to the signs and symptoms of heat-related disorder, and then the necessary steps to reverse that, and really plant that. Remember that this is the other side of that risk management. This is managing the consequences. And I'll come back to this as my second emphasis. Moving on to through the template is establishing heat stress thresholds. The basis for the template itself is, first of all, I like WBGT. Heat index really doesn't carry enough information, I think, to really be basing some the critical decisions on. I assume a metabolic rate of 350 watts, which is a little bit above moderate. So I think this is going to include most jobs that I've ever seen. And assume ordinary woven work clothing. So that's the basis of the template. I use degree C, by the way, because I don't want anybody confusing WBGT with air temperature. So in the US, if I put it in degree C, it would be like expressing it in Kelvin. They're not going to have a good relationship with that. And I think that's just fine. I talked to the woman who manages heat stress in the Disney Corporation. She told me the same thing. She uses degree C just to avoid that whole trying to relate it, people relating it in their minds to air temperature. And then these will be the levels of the thresholds for the different levels of heat stress, assuming woven clothing and a metabolic rate of 350 watts. The supplemental material, which I get into in the more detailed discussion, really provides methods of estimating metabolic rate and the time-weighted average if there are multiple tasks. And I always encourage a task analysis. Determine the effects of clothing, and then compute the heat stress level for multiple jobs. So you can have variable levels for different jobs if you're in a situation that you would benefit from that. For the estimation of metabolic rate, I rely on the ISO standard. It was recently revised as really a good model for several methods. Those methods I discuss in the supplemental material, and then they're also included in an Excel workbook. For now, shifting gears into the interventions at level 1, this is now many of the things that you'll see in the OSHA general recommendations: training, hygiene practices, surveillance, and heat-related disorders. Training, much as you might guess, annually or anticipation of heat stress. And it ought to include heat stress and strain, the recognition and response, hygiene practices, mind people of your policies, and then any local countermeasures. Heat stress hygiene practices, I put at the top self-determination. I'm not sure there's a real order to this, but I think it's so important that people limit their exposure, stop and rest when they really begin to have some significant discomfort, not minor discomfort, but significant discomfort, or begin to feel the symptoms of a heat-related disorder. Fluid replacement, we don't have to talk much about that, the importance of it. Lifestyle and diet, a good rounded diet and a healthy lifestyle. Don't do drugs. Get plenty of rest. Health status really breaks into chronic illness and how you explain to people that they need to seek the advice of their provider, as well as acute illness. Whereas a public health person, I say, don't show up for work. Uh, People are going to show up ill. And I'm going to mention later, then you ought to have a plan to deal with that kind of presenteeism. And then I put acclimatization as a hygiene practice versus a work practice. It's really a combination of both. So in combination with the policy is managing your own expectations about how you're going to perform. And if you're struggling in the first day, it's likely to get better on the second and then the third, and just adjust accordingly. The recognition in first aid, this is the safety net. This is where we really need people to understand what they need to do. And so I'm going to give you my view of how to recognize and present first aid. As you review other sources of how they describe heat-related illness in terms of the signs and the symptoms, the information they provide, and then also the first aid steps that they'll talk about, I'm going to remind you about the KISS principle of keeping it simple, stupid. And as I go through these, I think I've digested them the way I think that I've tried to keep it at KISS. And again, these are the professional kind of decisions that you have to make. I want to acknowledge in this particular section, first, I am a member of the Pocari Sweat Scientific Advisory Board, but the other thing is that I buttonholed a number of members who are really experts in heat-related illness to bounce my ideas off of them, and they've provided a lot of very useful feedback back. So heat-related illness. I want to emphasize today with you just the exertional heat illness. And I'm going to talk about three: a mild heat exhaustion, severe heat exhaustion, and heat stroke. But I'm going to tell you right away that that's not a continuum. You don't start with mild heat exhaustion, go to severe, and then go to heat stroke. There are plenty of cases where people will go straight to a heat stroke, and they won't display any signs or symptoms of heat exhaustion. So heat stroke really is a pernicious kind of heat illness that we need to be aware of. Okay, so mild heat exhaustion. Primarily, we talk about signs and symptoms, but mild heat exhaustion is just about completely identified by symptoms. You're not going to see things in people, but they'll report that they're tired and fatigued, possibly thirsty. They'll mention that they might be weak, dizzy and lightheaded, especially if they change their posture. And muscle cramps may or may not come along with it. And this is pretty reversible. You just inform your supervisor, recover in a cool area, and drink water with a salty snack or an electrolyte drink. You're basically, this is the early cardiovascular insufficiency, and you just need to get your blood volume back up and your blood pressure. And then note if symptoms persist for 15 minutes, because these things will really resolve very quickly. If they don't, then you want to move your thought process to severe heat exhaustion. And now here's where you're going to see both signs and symptoms. So things you'll see are unsteadiness, slow reaction time, obvious fatigue, muscle cramps, and vomiting. And they may report loss of appetite, nausea, and headache. These are really key indicators. You've got to watch those. Things are really now beginning to happen. Move them to an air-conditioned space. Encourage water or electrolyte drinks if able, and allow them to lay down. Watch for signs. Now you're watching for signs of heat stroke. You shouldn't leave anybody alone. Even with mild heat exhaustion, there always ought to be somebody attending to them, especially in severe heat exhaustion. Don't leave them alone. And again, that 15-minute rule of thumb. I've talked with some people about how they manage this, and they think once they get to the severe heat exhaustion, they're going to call EMS. I think that's a good decision, but that can still be a decision within the system. But you really, at this point, need to be watching for a possible heat stroke. And then heat stroke is symptoms free. Nobody is going to come up and tell you, I have a heat stroke. What you're in. So it depends solely on somebody looking at them and seeing obvious fatigue, rapid breathing. Really, if you start to see nausea and vomiting, um, that's important. What's different here is it's now not a cardiovascular insufficiency. You now have a central nervous system dysfunction. Fundamentally different. The brain is just going off kilter. And so when you see confusion and disorientation, garbled speech, hysteria to apathy, just marked personality changes, and of course, collapse or convulsions are good signs. Begin aggressive cooling. Ideally, you want to put them into an ice water bath. If not, just get them covered in ice. And if you don't have that available, anything else that you can dump on them or cool them down is going to be important. You have to call emergency services, advise them that you have a heat stroke. And then importantly, when we talk about emergency planning, if you call emergency services, you need to know where you are. And so how to guide them there. There's a video put out by the NFL that's excellent on heat stroke. The taco method is a nice, convenient way of managing heat stroke. So I just throw those out there. Really, in terms of notes, you want to diagnose it early. You want to make a mistake thinking somebody has a heat-related disorder that they don't, then make the other mistake. And then heat stroke really, really depends upon you seeing it happen. And then just as a caution, anytime a worker experiences a fading spell, they really ought to get medical approval to return to work, because it may not be the heat, it may be something else. Health monitoring, I'm not going to spend much time on this with you, but one is have a plan to deal with presenteeism, because ill workers, somebody with the flu and infection is going to show up for work. They're really going to be set up for a heat stroke. And so you need to have a plan to deal with it, either special attention or light duty assignments, whatever is going to work. And of course, with an emergency plan, you have them for serious injuries and illnesses. You're just going to add to that heat stroke. It's know who's in charge, and then who is the backup. Usually we think about the supervisor being in charge. I dealt with one case where the supervisor was the patient and you needed somebody else to take command of things. Now, know what to do. It's aggressive cooling. Know where you are, who you will call and confirm. Make plans to guide emergency services. Level 2 then is just based on the OSHA draft, and it's the hazard alert. So you let everybody know you've now entered a level 2. We are going to take a break every 2 hours for 15 minutes. And either you engage your buddy system or the supervisor takes responsibility for making sure he's got eyes on everybody. Level 3 interventions um, are mainly dealt with in the supplemental material, and it's basically the traditional hierarchy of control. So whenever you've learned about heat stress and what you do above the occupational exposure limit, that's kind of where you begin to bring in your tools and training. In the basic template, there's just a general instruction to slow the pace of work, increase the frequency and duration of breaks, rotate harder tasks if that's appropriate, and then specifically a 10-minute break each hour. So instead of 8 minutes an hour accumulated into 2, and then here a reminder, your risk is increasing now. You're making a decision to step up to level 3. Make sure you're on top of watching everybody. In terms of the supplemental materials, there's a lot of time spent on work rest. I want to give you a little bit of a clue. If you plot out the location of your work and the and rest in the same location, you're basically following the yellow arrow. And I want to point out to you that most of the proportion of that arrow is to the right of the OEL curve. And that means that work rest cycles are going to be incredibly sensitive to time. And you're going to find situations where a 1 degree C change in WVGT is going to move you from 45 minutes of work and 15 minutes of rest to exactly the opposite. 1 degree change will end up with a work rest cycle of 15 and 45. So this is not a circumstance that's really going to benefit much from work rest prescription. On the other hand, if the bulk of that arrow is over on the left side, then work rest cycles can be pretty effective. And what this really illustrates is it's rest in an air-conditioned space as opposed to resting in the same location. Okay, on level 4 interventions, what we do is we up that ante on risk assessments by saying the approval has to come from a second level supervisor. So the first level supervisor is going to get in touch with the second level, said, we're moving into level 4. Is it okay for us to continue, or should we stop work? That's going to be a decision that's going to be made by the second level. They ought to confirm that all the crew members have recent training, and you also hold a job briefing that you're now in level 4. You're going to have the buddy systems already in place. We add active query. In other words, it's a little bit discretionary, but certainly no more than every 15 minutes. You ask somebody, do you need a break? I like to pose it as, do you need a break, which is inviting them to say yes, versus can you go on, and inviting them to say yes. But at least you're making the decision conscious rather than subconscious. Personal cooling, things that are pretty effective if with a modest cost, is having forearm immersion in ice water. Does a nice job of reducing body core temperature. And at this point, drinking cold drinks or slurries has been shown to reduce body temperature and help tolerate these higher levels of heat. So I want you to remember that we have this risk management model, and that really ought to inform our actions. Here's some resources. Again, this website I hope to have up soon. It's not up at the moment. The ACGIH, looking to the OSHA approved. So when you see the slides, you'll see the links, and then of course the NIOSH criteria document. I told you I'd put up that QR code one more time. You can, this is now live. You're going directly to a document dump box. So if you go to that You can download those 4 documents that I've already discussed. Again, remind you, it's not copyrighted. We're doing a Creative Commons. The most recent version will always be at this website. And then if you do happen to use this, I'd love to hear about it. So send me an email saying, I helped somebody develop a plan, or we developed a plan. If you use it in your training and teaching, I'd love to hear about that as well. Got to tell my dean that I'm doing great things. And of course, we want to report this back to NIOSH that their money is well spent. I will protect your privacy. I won't use names or organizations, but if you give me a great quote, I will use it. And then, of course, if there are any suggestions for improvement, let me know. All right, Michelle, do we have questions? We have a little bit of time.
Excellent. Thank you so much for your presentation. We do definitely have some questions in the chat, and also at
Sure.
this point too, if anyone else has questions, please feel free to go ahead and enter them for us. One of the questions, do TLVs address the duality of heat stress and altitude sickness? And has OSHA considered this duality?
I don't think OSHA, I don't remember ever seeing it in their preamble. I do know that the Physical Agents Committee is looking into hypobaric exposures. We've been planning this for years, but I think they're making progress. What happens is I don't think there's a big interaction, but the reduced oxygen puts a greater cardiovascular demand on people, so that it's going to take away from the capacity to deal with heat. You generally, and you're talking about altitudes of going rapidly to 10,000 feet. Usually the problem is cold versus heat.
Thank you so much. A comment that I'm wondering if maybe you have anything else you'd like to add. We need to stress that policy, program, and standard operating procedures should also address outdoor as well as indoor environments.
They do. I'm a little bit vague. I'm hoping that both indoor and outdoor people use this template. And so we'll mention, if they're doing outdoor work, they ought to recover in the shade. If they're doing indoor work, they ought to go to an air-conditioned space.
Thank you. Also, a question about personal protective equipment. How is heat stress resulting from the use of PPE, for example, Tyvek suits, respirators, and gloves, addressed in the OSHA rule? And how do employers handle this generally to minimize exposure?
Yeah, the OSHA rule doesn't pick up much on this other than the fact that they recognize that they do it. The TLV does recognize Tyvek. Be careful when you use the word Tyvek. Sometimes that just means a particle barrier. And in the TLV, that's polyolefin, not mentioning trade names. If it's a coated, then you have to ask, well, if it's coated, it's likely to be impermeable. And so if you look at vapor barrier, that would be the one. If you're looking at a membrane, that might be also an impervious membrane, but it might also be microporous. Microporous is helpful. The problem is there's no specific guidance on microporous because the performance of microporous membranes varies widely. If you have that, give me a call and I'll talk you through it. Respirators, we published a paper a number of years ago that really demonstrates that respirators don't affect heat stress. That's just flat out, doesn't affect heat stress. Is it uncomfortable? Yes. Do you feel hot? Yes. Does it affect physiological performance? No. And we think we looked at the worst case, which was a full mask negative pressure respirator.
Awesome. Thank you so much for that information. It's very helpful. Another question, did you mention that if there was a larger list of clothing adjustment values?
I didn't mention, but there are. And I think it's in the supplement. And then again, if you can't find what you have there, we've got a couple of ways of handling that. And again, I welcome an email, be happy to talk those over. Working with protective clothing is tricky.
Thank you so much. I know you mentioned that you're not a fan of schedules. It seems like they may be difficult to apply to various jobs and work tasks. What do you think about the idea of having employees being involved in creating their own acclimatization plans or work rest cycles?
You know, the experts are confounded by this. And, to have the employees involved, I think there's employee discretion. I'd be a little bit worried. In that editorial, we argue that probably only 5% of the population would benefit from an acclimatization program. 95% of the people likely already have a heat tolerance above the OEL. And what we really do is it's that 5%, but it's also people who have for instance, a genetic intolerance to heat, or they're on medications or something. And we can't cast that net wide. We can't build a tailored program for that. So I think, again, this idea of increased vigilance, just encourage them to step up slowly, is just the best way.
Thank you so much. Another question, have you found EMS protocols to align with best practices in emergency cooling prior to transport? For example, if an employer initiated cooling, would EMS be equipped to measure the core body temperature or cool during transport?
Okay, so two things. Yeah, there are protocols, and hands down, ice water immersion is the best. The Army argues that towels soaked in ice water is good, and it probably is. So those are two that are pretty good. This taco method I mentioned is one designed for the field where you don't have a kiddie pool full of ice water available. The But then anything after that, talking to the physicians who deal with heat stroke cases, if EMS comes equipped to measure core temperature, they can do it. The rule of thumb that I didn't mention it, trying to get through this in the allotted time, is once they begin to shiver, you can bring them out. Otherwise, you wait until they get down to 39, 39 degrees. I think it's 39. I'm sorry. I don't keep core temperature in my head for this because I don't think anybody measures it.
Awesome, thank you. We have time for one more question. Have there been advances in technology to make good enough WBGT field instruments at a reasonable cost, or a phone
Yeah,
app that can slap together ambient temperature, humidity, wind speed, etc., for a good enough estimate?
I I think for outdoor work, the AIHA app is good. And I say that because it's been demonstrated in a published paper. Um, I can mention two others. Don't take them as endorsements, please. All right. The 3M, the Quest device, I forget now what name it goes under. I think it's still Quest, is I've studied it. And the other is that I've seen their in-house data, and it's incredibly extensive, that demonstrates that it works. I think God, I'm going to get the name misspelled or mispronounced. Um, the Kess, Kessler, I think it is. I think I saw a paper again demonstrating its validity. I need to grab a hold of that so I have it. I, but I think, if you're like a landscaping company, I think the app works. I appreciate the cost of having these things spread all over. If you're an indoor environment, buying a good, reliable instrument is not very expensive in the end. So that's kind of where I go on that.
Well, thank you so much for your time. Thank you for your question, answering questions. Also, thank you to everyone who joined us today. Thank you for your engagement and your questions. You will be receiving an email with a link to the evaluation form following it's about 12 or 24 hours from now. So you'll get that reminder email with the evaluation in there. And for those of you who asked for specific links, I'm going to go ahead and put those in that follow-up email as well. So we'll include that website link in the once it's available. Thank
Hey,
you. Oh, go ahead.
I was going to say, Michelle, I'll send you my slides immediately so you can get those links moved.
Oh, perfect. Thank you. Yeah, and I know someone else also asked for the citation around the physiological performance of respirators. So we'll do what we can to get those links for you
Oh,
all.
okay. Well, then get me a list.
Yes, yes, I'll work with you on that. Thank you, everyone, for joining us today. Thank you so much, Dr. Bernard, for your work, for your dedication to workers and keeping us all safe, and for sharing this information. We really appreciate it.
Well, thank you. And I appreciate everybody who attended.
Awesome. I'll talk to y'all soon. Bye bye.